Just a couple months ago, local AI models were a joke. The big labs would own our data, they would dictate how much compute we got, GPUs would be the new currency, and we were all going to be pushed into the permanent underclass. And that did not feel right. You can see how much power these labs actually have. They can decide to cut off your cloud access overnight, they can decide to gatekeep their best model from the general population and only release it to a handful of people.
Capabilities in a model like this could do harm, and so we won't be releasing this model widely.
So the AI labs keep getting more powerful while they own too much of our data. It genuinely felt bad that there was no local model that was actually usable. But something started to shift at the beginning of 2026 with the release of Qwen 3.5. This was the first local model that could somewhat feasibly run on your local computer and deliver Sonnet-like level of intelligence. For around 80 gigs of RAM, you could run a good model locally. The catch was the hardware. It was expensive, though honestly not that expensive. For 5 to 10K, you could buy a well-spec'd Mac Studio and run the model. But still a lot of people couldn't justify it. And then the ones who did buy these powerful machines were not taken seriously. Alex Finn, for example, spent 20K on a Mac Studio, said this was the future, and people laughed, called him crazy, said he was wrong. And to be fair, I didn't understand his reasoning either. Like, sure, you could spend 20K on a Mac Studio, but you're still running a model that is nowhere near GPT 5.4 or Opus 4.6. In fact, it's a bit worse than Gemini 3 Flash. Well, that was until a week ago when Google showed us what the future could actually look like. They dropped Gemma 4 and this thing runs on your laptop, it even runs on your phone. And for the first time ever, you can run a local model on your regular computer that is actually smart. Google basically handed us a free model that runs on your MacBook and has the same level of intelligence as the state-of-the-art model 1 year ago, which was Opus 4. If you want to try it, Google released an app called Google AI Edge Gallery. Install it on any recent iPhone or Android and give it a try. You could chat with Gemma 4 that's running locally on your phone. Anyways, bottom line, we've gone from needing hundreds of thousands of dollars worth of hardware to running this stuff inside our laptops. So I put the new Gemma 4 to the test in OpenCode, OpenClaw, and PyCoding agents on my MacBook, and I wanted to share what I found out. But first, let's take a quick look at Gemma 4's specs and see how it stacks up against the competition. This chart compares it to other open-weight models. According to Arena AI, it's basically smarter than most of the open-weight models, although the other models are much bigger and require much more expensive hardware like clusters of high-end GPUs to run. But I think this chart is a little misleading and overpromises the value. The model is genuinely good, but if you look at the artificial analysis index, the heavier open-weight models are still clearly ahead. So here's a table I made that summarizes everything we know more realistically, and then I'll show you how to run the model locally. At the very top, the current state of the art is GPT 5.4 and Opus 4.6, sitting at around 55 artificial intelligence score. Neither of these is open weight and neither runs locally. Then you have the smartest open weight models GLM 5 and Qwen 3.5, which aren't actually that far off in raw intelligence. The problem is that to run their biggest versions, you need to drop tens of thousands of dollars on hardware, so really not feasible for most people to run. And then there's Gemma 4. You can run this on a MacBook depending on which version you pick. Gemma 4 ships in several sizes. The small ones run on an iPhone, the mid-tier runs comfortably on a MacBook with 34 to 48 gigs of RAM, and the smartest version needs something a bit bigger, probably a MacBook in the 5K range. Now, in order to install any local model, or Gemma 4 in this case, there are two main options, either Ollama or LM Studio. There are other options, of course, but those two are the main ones. In this case, I'll be using Ollama. I'll just go to the website, I copy the installation command, paste it in my terminal, and let the installation complete. Using Ollama, you can download and run pretty much any local model. If you search for Gemma 4, you'll see there are several different options available. The first three are actually designed to run on your phone, and the sizes range from around 10 gigabytes to up to 20 gigabytes of RAM required. My laptop is a MacBook M4 Pro with 24 gigs of RAM, so just to test the integration, I decided to start small. You run Ollama pull Gemma 4 latest, that's the 10 gigs version, and once it's installed, you can open Ollama, chat with the model right there, and that's our first run of Gemma 4. Now for the real test, I started by downloading OpenCode, which is a coding harness, think of it like Codex or Cloud Code. I installed it, started it, and gave the model some coding tasks. Unfortunately, I quickly realized OpenCode isn't very stable when running Gemma 4 yet. The thinking often interrupted and tool calls were incorrect. The whole ecosystem around local models is still pretty rough around the edges, and there were open issues on GitHub confirming what I was seeing. So I switched over to Pi, the coding agent. This is a minimal coding harness, again similar to Cloud Code, but you're free to choose which model to use. For Pi, I actually tried to use the larger version of Gemma 4, the 18 gigs, 26 billion parameters mixture of expert model, which should theoretically run on my 24 gigs of RAM MacBook. But it didn't. My MacBook really struggled with it. I think for the bigger models, you need at least 32 gigs of RAM. So the smaller version was the only one I could comfortably run locally, though as you'll see later, I did eventually find a way to run the biggest model as well. So I launched Pi with the small Gemma 4 version and asked it to build a tic-tac-toe game. And I was surprised to see that Gemma 4 and Pi were a great combination. Much smoother than OpenCode and actually really fast. What you're seeing on the screen is the result. It went really well, the design is clean, the logic works, and remember, this is a small model that could run on your phone writing working code. But my exploration wasn't done. Next, I connected the smaller Gemma 4 model to OpenClaw, which would basically let me use OpenClaw for free, and started experimenting. It's a tiny model, but I was still able to do some things with it, asking about the weather in Sofia, Bulgaria, which requires the model to use a web search tool, and the result was successful. Pretty cool to see. Then I tested the vision capabilities, and Gemma 4 was able to analyze the image. It went really well, which is great news because this is a very token-intensive task. So you can delegate tasks like this to the local model and save lots of costs when running OpenClaw. In the future, I can see cost-efficient hybrid setup with the frontier models where lots of intelligence is required and local models for simpler tasks. Finally, I was determined to try the best Gemma model properly and test it on a real-world application. I went to RunPod and rented my own GPU, around 80 gigs of VRAM, which should be enough to run the largest Gemma model. After some configuration and setup, I connected my MacBook to the remote GPU so I could use the model from my laptop. Then I started again the P-coding agent, which based on my earlier testing was the most reliable way to run Gemma, and opened up my YouTube Copilot app. It's a thumbnail tool I built for myself, not a massive project, but not trivial either. Right now, its UI is built with GPT 5.4, which is why it's really ugly. So I asked Gemma to make it beautiful. Watching the model think through the problem was really cool. It was analyzing the UI properly, making real suggestions, proposing thoughtful changes, and reading the code. But the moment it tried to send too much context back to Gemma, something would break. Maybe the remote connection, maybe the RunPod, maybe the P-coding agent, maybe Gemma itself. I couldn't figure out the exact reason for the errors. And the error log from the coding agent, the server, and Gemma all looked good. But the workflow just wasn't smooth yet. It wasn't working properly. So I gave up on the big coding task and I will wait for the ecosystem to catch up and iron out the bugs. Finally, I asked the biggest Gemma 4 model again to build a tic-tac-toe game, and what you're seeing on the screen right now is the result. It looked better than the small model, had nice animations, overall nice to see. So based on all the experiments and research I've done, here's my takeaway. The local models are improving fast, combined with the new efficiency algorithms such as TurboQuant from Google. I think soon we'll have not just toys, but incredibly smart models running on our devices. However, I don't think Gemma 4 is as strong as marketed. The chart from Google feels very cherry-picked. I think the artificial analysis index is much closer to the truth, which is basically Opus 4 level of intelligence. Running anything genuinely capable locally still requires a decent machine, but the hardware is catching up fast and getting cheaper. The ecosystem is not ready. The harness, the integrations, the tooling, it's rough, buggy, and clearly early. But I expect the ecosystem to catch up big time in the following months. Overall, I think we're heading towards a hybrid future where parts of the work will run locally and parts of the work will run in the cloud. Anyways, I've shared every step I took to get these models running. If you've got a more powerful machine and you've done some testing, I'd love to hear about it in the comments. So please drop a comment if you're happy with your local AI setup. If you found a great use case, let me know. I'd love to learn. Thanks a lot for watching and see you next time.